So here's that solution, and then I'm just going to write it term by term. So let's write the n equal to 1 term and the n equal to 2 term, and then, well, we could continue to write all of the other n terms. But I just wanted to point out, to write it out term by term here. And in particular, I notice when I look at the n equal to 1 term and then n equal to 2 term and so on, that one of the main differences between these, aside from the x dependence, the way the n factor affects the n dependence, or the x dependence, is that the higher n terms decay faster with time. There's an n squared up in that exponential. And so as I go to higher and higher n, those exponential terms decay even faster with time. So once I get beyond the n equal to 1 term, these exponentials are going to decay extremely fast with time. Let's see what that looks like in the actual time-dependent solution. So we can plot the initial conditions, or the temperature of the bar for the initial conditions at t is equal to 0. So here I just included, I think, about 30 terms in this infinite sum. If you include more, you'll get a sharper looking profile. This is, of course, an approximation to the initial conditions profile that we had said, because we're including a finite number of terms. And so now let's go to later times and see what happens. So at later times, say t is equal to 0.05, we see that the profile is smoothing out. The sharp edges of the profile are due to the higher n terms, the high frequency terms, but the high frequency terms are decaying really, really fast with time. So this is smoothing out with time. And in fact, if I go to slightly later times, then I get a profile for the temperature of the bar that effectively looks like sine of pi over L times x, the n equal to 1 term. So as I go to later and later times, it just looks like the n equal to 1 term, which will then decay to 0, as we expect, as t goes to infinity. So you can get some intuition for this, that namely, if you put an arbitrary initial conditions, set of initial conditions on this bar, at late times, the higher n terms are going to decay, and you end up getting the low n terms for what the temperature of the bar looks like as a function of time.